Lesson 2, Automatic Data Movement. In this lesson, we're going to be talking about migration, moving the data through the storage pool hierarchy, reclamation, a way of reclaiming tape volumes that have expired data on them, and then co-location, a way to optimize your restores. We have this caution slide to make sure you know what the features do before you set them up. And notice they will have an effect. Generally, if you tune something so that it's a faster restore, it's going to mean a slower backup, and vice versa. So just be aware of these processes do take processing power and time, and how to best figure them into your schedule. Migration, we've talked about this a little bit. This is where your data moves from the destination pool to the next storage pools you have defined, and then to whatever additional storage pools you have defined. So your data is coming into the fastest disk in this case, moving down to a sequential access disk or file device class, and then ending up on a tape volume. These are all primary storage pools. Your storage pool hierarchy deals with primary storage pools. Therefore, these are not copies. This is the data that flows through the hierarchy using migration. The way we set migration is with thresholds. There's a high threshold and a low threshold. By default, the high threshold is 90% and the low threshold is 70%. This means when your disk volume is 90% full, it's going to kick off migration, and it will migrate the data until it reaches 70%. This way, you've made more room in your primary destination pool for the incoming data. You can set the migration high and low to different values. For example, if you set your high threshold to a higher value, it's going to delay migration. If you move it to a lower value, it'll start sooner. If you set your low migration threshold to 0, it will empty the volume. So in this case, it will empty the disk storage pool to your next storage pool in the hierarchy. This would take a lot of time. That's why we have it set for 90 and 70. That's the default, so that you're making just enough room for the incoming data. Technically, you don't want migration to happen during your busiest times. While you're backing up your data is not the time to do migration. As you'll see in a later unit with our daily maintenance, we can schedule it to run right before you kick off your data backups. That way your destination storage pools will be at their emptiest. At any time, you can initiate migration regardless of the threshold. Here's our command line syntax. Everything on the line is required. Everything below the line is an option. Everything above the line is the default. So you can set migration to run. You can give it a low migration number that would reset whatever you have as your default. So if you have your storage pool defined with a low migration of 70, you want to lower it to 50 for 30 minutes while you're running migration, you would do that with this command. Now you can also set up your migration values with the Administration Center. You do this in the Storage Devices tab, select the server, and then open the Select Action menu and click View Storage Pools. With your storage pools listed, select the storage pool you're wanting to modify. This would be the same as doing an update with the command line. Then click Modify Storage Pool. Here's where you then input the name of the next storage pool. You can't have migration unless you have a next storage pool. Then you can set your migration thresholds. That's a quick overview of migration. You'll actually be doing this in your labs, and you can see how the data moves from one storage pool to the next defined storage pool. Reclamation is a process of reclaiming your volumes. Expiration. We haven't talked about expiration yet, but trust me, data expires. If you're keeping 3 versions of a copy and you want to keep the last inactive version for 30 days, on the 31st day that last copy will expire. Physically, the copy is still on the tape. TSM just doesn't see it because it's been expired. So what it does is it basically leaves gap in your tape. You have good data and expired data. You're going to set a threshold. The lower the threshold, the more tapes and faster the reclamation time. The higher the threshold, it's fewer tapes and longer reclamation time. So you set a threshold, say when a tape reaches 60%, start reclamation. Your tape library is going to use 2 drives. It's going to move data from the volume that has 60% expired data onto another volume. Then you're going to have an empty volume you can return to the scratch pool or a private pool. Now don't worry about scratch and private. We actually go into that in the next unit. Collocation. Collocation is a way of collating data. You can set collocation by file space, by node, or by group. This is an example of collocation by node. This means that all of the files for client node A are written to one volume. All the files for client node B are written to a different volume. So when you're doing a restore, you're only mounting one volume. Now this is obviously a simplified example, and there could be multiple volumes involved. In volumes without co-located storage pools, the data is mixed. You might need to mount 2 different tapes just to restore client node A. Benefits: you're keeping your client data together. You're going to be using fewer tape mounts during restore, therefore a shorter restore time. The cost: you're going to be using more tapes, and you're going to have more processing on the backup side because you'll be mounting all the different tapes for your backups. Where do you want the benefit? The restore or the backup? Most people would say the restore. Most data owners don't care about a backup. All they care about is the restore. Tape volumes today have much larger capacity, so you might have a lot of underutilized tapes if you set collocation by file space or by node. So how does TSM figure out where to write your data? If you have collocation equals node, it's first going to look for a volume that already has that client data. If that's not there, it's going to look for an empty predefined volume, then an empty scratch volume. And if that's not available, if there are no empty volumes and no volumes with space that already have that client node data on it, it's going to look for the volume that has the least amount of data, the one with the most free space. Now even more granular is the collocation equals file space. First it's going to look for other files from the same file space. Then it's going to look for an empty, predefined, or scratch volume. If that's not available, it's going to look for a volume that has data at least from the same client node. Then if that's not available, you will go with the volume with the most free space. Here's our example. Client A has its own volume, Client B has its own volume, and Client C has its own volume. Time to back up client node D. There are no volumes for client node D, but we do have an empty scratch volume. Scratch volume can be used for any request. It's not already identified to a specific backup. So we would be using a scratch volume. Same scenario, but we don't have any scratch volumes. The only almost empty volume has a database backup on it. Here's a tip. You cannot store database backups and data backups on the same volume. So in this case, client D's data would go on the tape for client node A. It has the most space. Hopefully you'll never have this scenario because you'll always have enough scratch volumes handy. Collocation by group is a way of addressing you're still doing collocation, but you're not dedicating one tape volume per node or file space. So it's a better utilization of your tape volumes. Basically, you define a group however you want. It can be by data owner, by department, by location, alphabetical listing of servers, however you want to define them. Once you've defined your group, you then set up the co-location by group. You've given the group a name and you add the members. So in this case, we have a group called Sales, and to it we've added these 6 nodes. We have another co-location group called Accounting, and we've added these 6 nodes. You can use co-location with active data pools. This is handy because you can use the simultaneous write function, which we're going to cover later in the course, to write to multiple storage pools at the same time. So when you're copying data, you can copy to an active data pool as well as just a copy pool that has active and inactive. Using the Administration Center, this is a list of the features you can use in the Storage Devices tab. Here you've got your reclamation, migration. All of this can be managed with the Administration Center or the command line. Here's the wizard that you're going to use for your copy to active data. We'll also use active data pools, setting them up with command line. I want to give you a high-level overview of data deduplication. This is a feature that saves a lot of time and storage space. So it saves your time during the backup process, but it adds time in additional processes. In the first part of this lesson, I talked about some of the cautions. This is one of them. Data deduplication has a great benefit in reducing the amount of storage and reducing a lot of the time of backing up data. However, it's offset by the time it takes to run what's called identify duplicates. We don't do a data deduplication lab in this class. It's more of an advanced feature, but I wanted you to know about it. What TSM does is it backs up one copy. Then for the redundant copies, it just has a pointer to the unique data copy. You're going to reduce the amount of data you store and reduce the amount of time for doing a retrieve. So when you're restoring your data, TSM knows in the database it keeps an index and it says, oh, that's actually a duplicate copy and I only have one stored, so this is what I'm giving you back. It's one of the copies. There are 2 methods for using software-side data deduplication. Server-side means all the data is moved to the storage pool that is set up for deduplication, and then TSM sorts it out and only stores the unique copy and then makes pointers to the others. Client-side is a way where the processing happens on the client side. The client shares the workload with the server. Now, if you're running client-side deduplication with caching, the client doesn't even need to contact the server to say, have I already sent you this? Then the client knows only to send the unique copies. The server will contain the index in the database where all of the copies come from and where the unique copy is stored. Basically, each object is divided into a logical segment called a chunk. Next, you identify the duplicate chunks. One copy is stored, the other copies get listed in the hash index. Then the redundant copies are removed. When you need to restore a duplicate copy, the TSM database knows where the unique copy is stored. It also knows where all the duplicates belong. So the database will sort this all out and you're storing fewer copies. This concludes Unit 4. You should now be able to describe the purpose of the storage pool hierarchies, and storage pool volumes. You'll be able to create storage pools, move data. You'll be able to design and configure storage pools based on customer requirements, and you can manage storage pool volumes and your data. You can now perform the exercises for Unit 4. You'll need to complete these exercises before you're able to do the exercises in Unit 6.